wants to see it, but doesn't want to necessarily join the Zoom meeting is able to. I'm going to make sure that everyone can chat if needed. Okay, cool. Okay, cool. All right. Okay. All right, I'm going to go ahead and also put up our entry poll. It's just 4 questions, so if you can go ahead and answer those. We'll go ahead and have that running for a second, just to give people a chance. And then we'll get started. Go ahead and also put up our entry. And then once everyone has a chance to answer that, we will go ahead and get started. I want to confirm that everyone can hear me. So if you can hear me, go ahead and post in the chat that you can hear. You can just post yes. To use those of you just joining, I do have the entry poll posted. And I'm asking that anybody who can hear me, if you can, please go ahead and post in the webinar chat. You should see a chat function on the bottom portion of your screen. Go ahead and just send a hello or I can hear you. And then we will get started. All right, it looks like everyone is completing the poll. So thank you to those of you who have. Still waiting for 2 more. And then we should have a few more people hopping on with us soon. So I want to just give them a second. It is 7:03, so we'll go ahead and get started officially at 7:05. All right. Okay. I'll let the poll stay up for just a little while longer, just to see if we can get any more respondents. All right, and then I'm going to go ahead and share my screen. Okay, so before I share my screen, I do want to point out a few things. As we go through, you can, if you have a question, you can either type it in the webinar chat, and I will do my best to make sure that I'm checking those frequently. You can post in the Q&A. That'll open a question, and I'll either answer the question as we're going, or I'll wait until the end of the segment to answer questions, kind of depending on what the question is and when I'm able to see it. And then other than that, if you have any questions or if I'm going a little too fast, just let me know and I will slow down. So let's get into it. It's 7:06, so I feel comfortable going ahead and starting things. So my screen should be shared now. If you cannot see my screen, please post in the chat so that I know. From my end, it looks like it's working well. We are talking today about coding languages, different use cases, and we'll talk about some resources. And then I will send out an email that has this slideshow as a PDF. So you should be able to get that as well after we're done here. So first, let's just go over quickly what we're going to talk about. Coding language really broad, sort of the high school age. And I'm just going to check something really quick. Okay. So after that, we'll talk about some concepts that are important to CS. This is important because it will give an idea of why we're talking about certain coding languages and why we might not be talking about others, and the importance overall of recognizing why we're learning certain languages or why other languages might be good for a time, and then moving on to different things as we go. We'll finish up just by talking about what programming looks like in the adult world and any other benefits to coding at a younger age. So if we don't have any questions, we'll go ahead and move into it. Our first language that we'll be talking about today is going to be Scratch, followed by Python, JavaScript, Blockly, Ruby, Swift, Java, and Java Blocks. We're going to go over some pros and cons, recommended ages for each language, and some resources that could be useful in, in learning or in trying to pick up things or in using these languages. So first, we're going to talk about Scratch. Some of the benefits to a student learning Scratch or picking up Scratch. Generally, it's one of the beginner languages. It's block-based programming. You can see in the bottom right there. It's ideal for beginners, and it's fun for creative projects. To make this language easier for beginners, the shape of each block clues the child on when to use it. Blocks also have colors that allow younger coders to make mental associations with different types of concepts. So you can see in the bottom right that it's more user-friendly because it's not saying a formula like this is a class or this is a variable. It's telling you exactly what's going to happen. So when you click the green flag, you're going to set the score to 0. And it's a lot more user-friendly, especially for really young kids, like 8 to 12. It helps them to understand how computers work before they pick up on commas, curly braces, semicolons, or having to understand what a variable is, what a class is, and how to use those different things. One of the cons, which isn't necessarily a con because of the use case for Scratch, is that it doesn't have really complex applications. It is great for what it is great for, and that is for younger students to pick up an understanding of how computers think. The recommended age, like I said, is around 8 to 12. Students can make interactive stories or develop small games. The Scratch website, there's online tutorials, and there's even a Scratch education community. So we'll have those links sent out once we're all done with our meeting today. The second language we'll talk about is Python. Python is a really well-known language. We get a lot of requests each year or even each semester for more Python classes. Some of the pros are that it is a simple, readable, versatile, language, and it has a lot of real world. And I say adult, not in the fact that students cannot do it, but by adult, I just mean like careers or career focused individuals. There's a lot of use cases for Python. One of the cons is that the syntax does not always express the deeper technical ideas. The recommended age for this is 10 and above, kind of depending on when you started working with coding, what language you started learning, and just general overall sort of self-drive. A lot of Python is used in web development, automation, robotics, machine learning, and AI. Some resources are Codecademy, Python.org, and then there's a Python for Kids book. In addition to the KT-Byte, we have a Python coding class sequence that directly links to our machine learning and AI. So like I said, after this, we'll go ahead and give you the links that are related to these things. And as we're working through the languages, we can also take questions or comments, concerns, if you have them. The next language is JavaScript. So JavaScript is different from Java. This one is useful for web development. It is dynamic and it's interactive. A lot of times with JavaScript, you don't have all the libraries built into it that you might need. So you might have to download extra libraries or use extra libraries. And there are some concepts that can be considered confusing, especially to younger students. So the recommended age is 12 and up. A lot of web developers use JavaScript. It's more of a front-end language. And you can also make browser games. So if you're thinking of like the Dino Jumper game or games like that, those are simple. That's a simple sort of idea, but that is used with JavaScript. That uses JavaScript. Some resources outside of KT-Byte, because we don't have JavaScript classes, would be Khan Academy, and then there is the Mozilla Developer Network. Blockly is another language. So it is a visual and it is block-based, and it is used in Google's first computer science curriculum. For this language, it's kind of hard because there's limited real world application. That doesn't mean there are not benefits to learning this language. It just means that if you are at an age where you're trying to learn something so that it has a specific use case, this might not be the best language for you. Each computer science language, we should remember, there are pros and cons to each of them. And so it's just more about thinking about what your student needs are, what your goals are with computer science and where you're hoping to go, more than it is about how much they'll use this specific language in different areas. Because if you especially have a young student, having different options for that student to begin learning computer science is really important. So Blockly and Scratch are both really good for that. Scratch, I think, is more well-rounded, but I don't have as much experience with Blockly. So it could be that Blockly is also very well-rounded, but we just don't have as much interaction. So this one is primarily used for just teaching programming concepts. And obviously the Blockly website and Google CS First are the two resources that we can list here. So these two languages, I put them on the same slide because we don't use them a ton here. We don't use them at all. And then in the real world, there are less applications and they are for an older age group. So on the left, you can see is Ruby. It's easy to read, beginner friendly. It's not really used in the industry much, but it is used in web development or scripting when it is used. Ruby for Kids book and RubyMonk are the two resources. These are both for, like I said, older students who probably have experience in a different language. This isn't one you want to start out in for sure. And then Swift was developed by Apple to create iOS apps. It is limited to the Apple ecosystem. So if you are creating an app, keep that in mind because If you want your app to be able to be used across both Android, Apple, and other types of phones, this might not be the best way for you to go. Obviously, this isn't going to be something you start off in. You'll probably have to learn a different language and then potentially also learn Swift. But it is a language that's out there. It has a use case and it's beneficial in some ways, but definitely not something we'd want to start off with, but useful in its own way. The resources here are listed at the bottom. Swift Playgrounds and then Apple's Swift website are the two for Swift. Moving into Java, if you are a Katie Byte student, have been a Katie Byte student, are hoping to be a Katie Byte student, you know that we use Java a lot. It is a very widely used language, similar to Python in that, and it is very well defined, which is a little bit different from Python. This is a really common language for high school student exams and competitions, which is the primary reason that Katie Byte uses Java as our primary core curriculum language. Standard Java does need more starter code, and some of that code can be verbose. It can be very overbearing. There are two different sorts of Java, especially here at Katie Byte. We have created Java blocks for our internal system. That is a drag and drop language similar to Scratch and Blockly, but different in that it does use the real function. So it uses all of the correct syntax, but students don't have to worry about semicolons, colons, curly brackets, making errors in those things. But it is not the same layout as Scratch in that it says, click here, do this. It is using the correct commands that would be used in Java. So it offers the flexibility of drag and drop, but we'll get more into that in a minute. The use cases for standard Java include Android app development. You can also develop apps for Apple, and then software development, Minecraft, and other games. You can also use this for backend development. Outside of Katie Byte, there are a few different options. So Java Books for Kids, we have self-guided lectures, Codecademy, and obviously there are also Katie Byte courses. We also have some, it's called the Katie Byte textbook on Java. So something to keep in mind, and that's the main reason that we use Java, is because for students in high school, going to high school, want to compete, want to take AP exams, it's important for Java to be at least within their radar, because the APCSA exam is taught in Java. But Python can also be used in some computer science competitions. So it's a good language. It's just a little bit different. So we're always thinking about use cases and what best serves a student's needs. So that's kind of what you should be looking at when you're going into picking what language is best for your student. We were talking just a little bit about these. These are sort of subsets of Java. So processing, it teaches Java without as many rules as standard Java, and it does have visual program output. It is not used for coding competitions. You do need to use standard Java, and its recommended age is around 10 to 15. So art and graphics, game design, and just educational purposes are using processing. Our Core 3A to Core 5A courses teach processing primarily. It happens in the coder, so you don't have to download anything, and all the libraries are sort of built into the coder. And then Java blocks, some of the pros are that it's visual, it is a drag and drop coding language, and it also teaches Java syntax without the necessity for typing speed, or it kind of takes away the frustration of forgetting a comma and looking forever for your syntax error. The cons are that it is limited to block options, and that could feel restrictive or difficult for students who are kind of at that age of 12 or 13 and they want to be typing, but they are still learning the Java syntax, and hopefully as typing speed improves you'll be able to move on. Some of the use cases are teaching programming concepts and Java syntax, which differentiates it from Blockly and Scratch, because there is a direct correlation with the larger language of Java. Our courses, Core 1 and Core 2, Core 1A to Core 2B, all use Java blocks. So that's a little bit of information there. And then while we're thinking of kids as they grow up, we kind of want to think about what benefit these languages might have for them. So we're going to go over a few things. We'll talk about some computational principles, what programming looks like for adults, and the benefit of coding principles overall. So we'll go over on the right, you can see we're going to talk about language agnosticism, languages and uses, job opportunities for adults. So children who are kind of maybe want to move into the CS degree field. And then we'll also talk about some skill development. So far, I'm not seeing any questions or anything like that. So I will pause for just a second. If anybody has any questions, feel free to post them. If not, I will continue in just a moment. All right, I don't see any questions, so I will keep going. And let's get into it. So language agnosticism, obviously this slide is pretty bare, but the idea of language agnosticism is that there is an ability to switch between coding languages. And this isn't just the ability to switch between coding or programming languages. This is also the idea that you're looking at a problem, and instead of thinking about how can I make this work in Java, the idea is having an understanding that sometimes, especially as you're getting older, and maybe you're later in high school, maybe you're 17 or 18 and you've been able to work with a few coding languages, or maybe you've done robotics, you've kind of given yourself more of an understanding of different types of coding languages, that you can understand how a problem can be resolved, whether it's using Java or whether it's using Python or what have you. It's the idea that your problem solving ability is strong enough that you don't necessarily have to solve the problem in Java or Python or one specific language. So the first portion of that obviously is maybe knowing 2 programming languages, maybe knowing 3, maybe understanding how programming languages function. And a lot of times, once you've been able to do that, you can switch quite easily between coding languages. You do have to have a certain level of mastery of one before jumping around. But once you're able to understand how they work, then the implementation and how you choose to solve the problem and what language you choose to do so with is kind of where you're going with language agnosticism. The reason that I bring this up is because at Katie Byte, we primarily teach Java. And some students really want to learn Python. Some students really want to learn C++ at the start. And the reason that we teach Java is because we've created Java blocks so that young students can even get a foothold in Java. From there, we move to processing because it's a way to keep students both entertained and learning. And then from there, we're moving to the full-fledged Java. And while we know that there are plenty of other languages out there, and there are great use cases for each, generally we kind of take the idea that once you understand a language, it is much easier to swap between languages, and mastering one language that is well written and used across a lot of different use cases. Once you understand that, it is much easier to swap to like C, C++, C#, whatever the case is. So that's a little bit of why I wanted to talk about what it means to be language agnostic and what it means for us to want students to learn Java first, or that is why our entire curriculum, the core curriculum, is based on Java. Let's talk after that a little bit about types and uses of programming languages by adults specifically. And this doesn't mean that younger students or people cannot get into these different, and it doesn't even mean that younger students aren't doing these things. I know plenty of high school students who are making apps, who are doing data science and analysis, but I wanted parents to kind of get an idea of what the benefits of learning these different languages are, especially for students who may want to go on to CS, who maybe are not sure about what options are even out there. And what does that mean as far as what language you might want to use, or even start co-learning. So obviously the first one that comes to mind is web development. But I know that for myself and for different people, the idea of web development is very large. And we have a hard time of figuring out what does that even mean. So when you think about web development, we break it down into 3 different categories, which is full stack, which means both front and back end. There's simply front end, or there's just back end. Web development, in simpler terms, is the process of creating and maintaining websites, making them look and function the way you see them on the internet. There's also a component here of UI and UX design, which is user experience. So that also plays a role in this, but specifically the individuals who are doing most of the code are the developers. The back end is maintaining the function. The front end is usually maintaining the visual aspects and making sure that things are working correctly. They're organized in a way that people can understand. Buttons look good, they work how they need to, and things like that. So on the front end, you're mostly using like JavaScript. You could be using some CSS. And then on the back end, you could be using Python, I think in some cases. Java is a big one on the back end as well. And I think some of the C languages. But that's our first category. So that's kind of I think the most well-known. And then you're thinking of mobile app development. So when you're thinking of app development, obviously Swift comes to mind because we talked about how Apple made that language so that you could develop apps on Apple products or on the Apple App Store. And then obviously Java can also be used. And when thinking about mobile app development, it's building applications for your phone. So it's the process of creating the apps that anybody can install, like games, social media, and they use, obviously, like I said, Java or Swift. Moving through, we're thinking about data science and analysis. So if you're really good with numbers, you like analytics, maybe you like higher math classes, this could be a good space for you. This can use Python or R. Data science and analysis are kind of like detectives for data. It's the practice of using tools like Python or R to explore and understand very large sets of information. And you can find patterns, make predictions, or even help a business make decisions. So that's another area where sometimes we think that just uses math or, how can coding help here? But obviously it's taking a lot of data and it's able to sort through all of that data much faster than a person can and with more accuracy generally. So there's also system and software development. So this is creating operating systems, whether it's for a computer or for something else. You can design the apps that you're using, building software that makes computers and devices work. So this will often use C++ or C#. Database management. So this is a person who will organize, well, it's not that person, but the person who does the database management is using SQL to organize, search through libraries, sorting, managing, retrieving different data and doing it efficiently from a lot of different places is called database management. And that usually uses SQL, which is also called SQL or MySQL. And our list, which is not an all-inclusive list, but it's game development. A lot of students love to play games, and that's part of the reason that they get really into coding. And so game development, obviously, is creating some interactive stories. It's creating adventures. And then you're also creating players, deciding how they work, deciding what they can and can't do. So making rules, graphics, and usually this will use C++ or C#. Obviously, we just talked about some job opportunities, but these are kind of the industries that are available, as well as some of the benefits in different options. Obviously, with all of these, there is a higher earning potential, remote work, people get to learn creative problem solving, and obviously with the constant ebb and flow of computer science, there is always a space where you're continuing to learn and develop your skills. So this slide, I know that a lot of students aren't at the place where they're going to go into app design right now, or looking for a job, or sometimes if you're just 8, 9, 10, if your student is pretty young, the question is, why is it even beneficial to learn coding? And a lot of that is for skill development. So we're going to discuss the long-term benefits of coding and how it can shape a future. So students who learn to code are also learning problem solving, logical thinking, creativity, adaptability, career readiness, obviously, interdisciplinary skills, life skills. And each of these kind of have a nice little definition or just a bit more information. But from a young age, if we can kind of instill or inspire students to figure out how to solve a problem, and with technology being on the rise and kind of in every position, whether you're somebody who works on homes, or if you're someone who works in a restaurant, or if you're just someone who has a phone, then you're always going to be affected by technology. So understanding how it works is beneficial on its own. From there, students learning logical thinking, it gives them reasoning and structure, which honestly just helps as you're growing up through the world. And then obviously we're going to go down, and creativity is cool because even though programming has set standards and rules, there are ways to use code that can make beautiful pictures. They can make fun things. You can make apps, games, websites. So there's a lot of different ways to apply what you're learning. And sometimes when you're thinking about coding and where to even start, thinking about those types of things are so far down the horizon that we're not even going to get into it. But it is good to think about if, you're already in coding a little bit and you want to know a few different ways to apply what you're learning. Lastly, I would just really encourage anyone, students, parents, explore local coding clubs, online things, coding camps. I know that we also have a few, they're not clubs, but groups. We have a Facebook group for coding competitions, and I can link that if anybody would be interested in going there. We post scale, and we post videos to either prepare for competitions. We're always looking for new competitions and different ways to share more information with our students. All right. So if there are no questions, comments, or concerns, that'll wrap up kind of our informational portion. So I did put up the exit poll, and if you'd like to, you can go ahead and finish that. It's just 4 questions. And today we were able to talk about lots of different things, ranging from various coding languages, concepts that are important, and what coding looks like even in an adult world. So if you have any questions, feel free to stick around. You can ask them in the chat. If you don't have any questions, you can just finish the survey and hop off. I will also try to send out either today or tomorrow the slide deck along with some links to useful online resources for students. See, everybody is participating in the exit poll. Thank you so much for that.